In this video, we're going to take a look at a transformer, and a specific one. It's a compact one called DistilBERT. So we're going to use a Python script to connect to this DistilBERT transformer. A transformer, again, is just a specialized neural network architecture that's designed for processing and analyzing data such as natural language, oftentimes used for log files and other security events. You see this used a lot in a lot of the natural language processing tasks. They're the foundational architecture, transformers are, for a lot of our modern large language models, LLMs, ChatGPT, Claude, Gemini, all those, for example. So again, I've got a Python script here that I'm going to use, and this is DistilBERT is a compact transformer module that's specifically for text classification. So what it does is it's going to output a negative for any hostile or frustrating language, and it's going to have a confidence score. A confidence score of 1.0 means it's very strong, very certain that this model is that's a negative text message, a negative connotation to that text. Real deployments will combine model output with human review. Here we're just going to go ahead and just use this model as it is. So what I have here is I import transformers from a pipeline. So what I had to do was I had to make sure that I used my Python. I had installed Torch on this to be able to support and have these different libraries. And I load up the pre-trained DistilBERT model, basically to decide whether this text is positive or negative. And the specific model that I'm here using is this DistilBERT-based uncased, fine-tuned SST2 English. So I load up that module, and then I feed it some sample text for it to analyze, right, to give that confidence score. Remember, a confidence score of 1.0 indicates very strong model certainty about its prediction. And then as it's less certain, we're going to get lower scores here. So let's go ahead. I've got a series of text. And then in my text, I've got some comments here. Remember, in Python, the pound sign is a comment. It has no bearing on the output. These are just my guess of what this text would come back if I were manually going through. So most of these are negative, but one of them I have here, network traffic normal, no issues found. The expected result there, that would be a positive thing, I would think. But suspicious file detected during scan, that would be negative. Multiple failed login attempts detected, that would be negative. System update complete successfully. Generally, I would think that would be positive because something finished successfully. Now, if it's happening at an odd time or something, that may not be so positive. But again, we're just looking at the text message here and not any other context around this. And then high packet rate, possible distributed denial of service attack. I would say that would definitely be negative. Okay, and then I have it go through and print out what the DistilBERT model came back and classify each of these strings of text as. So I'm going to go ahead and run this particular script, and it gives my output here to this window here. So it's starting, it's loading up that model, and here we go. Here are our results. So suspicious file detected during scan, it came back as negative with a very high confidence of 0.98. So 98% certain that that's negative. I'd agree with that. Network traffic normal, no issues found. It came back and it gave that a grade of negative. Now, when I reviewed it, I would say that that is a positive sentiment. So that's interesting that it came back as negative. And well, we'll talk about a little secret here on why that actually came back as negative. But going on here, multiple failed in login attempts, negative. I concur with that. And again, it has a very high confidence that that is a negative result. Likewise, the next two are very high. System update completed successfully. That gives a positive result, very high confidence, 1.0. Can't get any more confident than that. And then high packet rate, possible DDoS attack, it rates it as very high. So you might look at this and say, man, it did pretty good, but it did let something go through the cracks there. Okay, so why is that? Why did it maybe misinterpret something that maybe to you and I was, well, more obvious that, hey, that should have been a positive result if network traffic is normal? Well, here's a little secret that I didn't tell you. The model returned negative rating for network traffic normal, no issues found, because there's kind of a mismatch in what the model was originally trained to do and the security data that we gave it. Okay, the specific model, the DistilBERT based uncased fine-tuned SST-2 English, that model that is entirely consists of movie reviews pulled from Rotten Tomatoes. Right? So here it thinks it's evaluating a movie, not security log files. Okay. The other thing is language models place a massive amount of weight on strong words. Okay, and specifically, remember, this was trained for movie reviews. So words like normal and issues, well, those could have negative context clues where it comes back and it says this is totally negative. So again, remember, when we select a model, what was it trained on? What's that data? All those are very important to make sure that you're choosing the right model for the job. So to fix this, we would probably use a different model altogether. All right, I hope that helps. Thank you very much.